Has everybody had their coffee already? One of the benefits is, and first of all, I want to thank the committee for letting me speak today. One of the benefits of the role that I get to play is that I've always been in the OEM business. That is quite the challenge, as it's mentioned before. And from an engineering perspective, I have to remind people every day that we went to school ultimately to solve problems. Either though people don't understand that, we are actually the ones that actually have to find all the solutions, whether they're regulatory, whether they're our customer, or from any other perspective to push the industry. So one conversation I started having with a couple students in school, trying to put a little perspective around how an OEM tries to go through this, is that it's two ways. One is the technical challenge in order to meet emissions. That obviously pushes the technology to a level that ultimately we're here today. And then the other side is just getting the actual cert. The technologies that we've been trying to validate and implement in today's industry ultimately drove about half of our time. And as we've mentioned before, now we're spending significant amount of time in order to go through the homologation process, make sure that we have the proper data to support that, and then relate that overall to the real world. So before I start to get into the technical side of how we went through Tier 4 and then how Stage 5 is being implemented in Europe, I'll do a little bit of background in terms of FPT and what that business represents. So ultimately, FPT, from a North America perspective, many people won't recognize that name. But ultimately, many will recognize the Case New Holland or CNHI Industries name. That conglomerate itself spans quite a lot of the industry. If you look at it, we're on-road, we're off-road, the construction industry, special vehicles from an overall military perspective, and then overall power generation, and that's where FPT ultimately comes into play, is that FPT supports and provides products for all these applications. So again, hence that's challenge again. From an overall global perspective, the overall production amount is about 500,000 engines. We also have product that goes in our captive customer, which is the CNH, Case New Holland, and then also what would be Iveco. And then also we sell off-road and also to non-captive customers. So quite a variety of applications to be able to serve. There's also transmissions and axles, but obviously we're here today to talk about a lot of the content from an overall powertrain perspective. From an overall product perspective, and then I promise to end the overall company overview, it's quite a large range of products. We're talking from 2 liters all the way up to 22 liters of products that go both on-road, off-road, and then power generation and marine. So now what I'd like to do is try to move on to ultimately how the emissions regulations are starting to drive what we are doing, and as we heard before, ultimately what would be the Tier 4 and now Stage 5. So as you look at where we sit today, ultimately you have the main regions in terms of where we are with some non-regulated, now Stage 3, Stage 4, and then ultimately where we think things are going to be going from a Stage 5 perspective, primarily in Europe, and then who knows what that's going to be here in North America. But ultimately, I think my speaker before me ultimately set the stage in terms of where we sit in terms of the regulations, so I don't need to go any further than that. From an overall perspective, where the legislation was from Europe, in 2011, there was a reduction in PM. We talked about that in terms of Stage 3, where ultimately the major part was particulate NOx reduction. And then after that, in 2014, going to Stage 4, Tier 4B, we would end up going to further NOx reduction. So ultimately, the engineer's challenge is, how do you solve that problem? There's 2 approaches. Obviously, you can do it internal to the engine, and then obviously what happens south of the engine. So there's always many manufacturers go back and forth in terms of ultimately how to play that trade-off in order to optimize the performance of the engine and ultimately serve the customer in terms of what they're doing, whether they're taking goods day to day on road, or whether or not they're using the machine to plow the field, or whether or not they're using it to actually do some construction. So what I'm going to walk through in the next couple slides is ultimately how our company went through the process of making the decisions it made to go through that, and then obviously other OEMs have gone through these trade-offs as well. So ultimately, as we look at what would be a high SCR or a high EGR, low SCR system, from a stage 2, most of the industry ended up doing it from a combustion perspective in order to reduce particulates. Then ultimately, going forward to a stage 3, EGR could be introduced in order to get the NOx down. And then ultimately, you have to look at what are those trade-offs in terms of the EGR rate and then what the cooling requirements are for these machines. As we talk about off-road, there's very different demands for an off-road machine versus an on-road machine just alone from the cooling pack. You don't have ram air like you do on a big truck on road. So then ultimately, as we go into the stage 3B, the further NOx reduction required additional treatments such as SCR. So there you look at the trade-offs in terms of efficiency and overall the amount of consumption in terms of urea. So now what I'm going to do is I'm going to look at what would be the difference between a high EGR and what I would say a mediocre or mid EGR amount of solution in order to get there. From there, all you see is the amount of efficiency that we have to require in terms of the overall SCR system. Urea obviously goes up, and then the trade-offs that you get in terms of fuel economy and ultimately what we have to require for cooling. So there is some improvements from an overall perspective in terms of vehicle requirements, but then obviously there's some changes in terms of what that would require from the customer. So then moving forward, another item to look at is a low EGR rate and what would end up being a higher amount of SCR. From there, you look at a little bit that would go down to stage 2, and then ultimately using SCR to get all the way down to what would be a stage 4 or stage 5 system. Then the final, which is ultimately where FPT is parked, is that we are using overall SCR systems in order to get all the way down to what is a stage 4 system in order to meet the best trade-offs and overall fuel economy that's used up at the top. So we talked a little bit, the speaker before us ended up talking a little bit about with or without a DPF. So as you see the competition in terms of stage 3 or stage 4, some are using it depending on if they're using EGR or SCR only with a DPF. And that's for what would end up being a stage 4. But for anything past a stage 4 going into a stage 5, based on the particulate requirements, you're going to need to have an overall DPF. So ultimately, I don't think I want to spend too much time going through this slide because everybody has seen what an overall after-treatment system is. You have a DOC catalyst, you have the urea injection, the SCR system, and then a cleanup catalyst overall to look at that. And the OEMs have always had the challenge of how to package this on a machine, make sure that it's in an area that's clean, that it doesn't have high vibration, that it's robust to do what it's needed, and also to optimize the temperatures in the system. One of the lessons learned so far that's happened as FPT has gone forward with a high SCR system solution is overall how to model what is going on in the SCR catalyst. A lot of that has to do with the storage in terms of the NH3 and how much urea is used in the brick itself. This, in essence, I related back to my days when I was on road in medium, which was optimizing what was the particulates amounts that was in a DPF. And it's very, very similar. Those trade-offs that you look at in terms of making sure that you have the proper storage and usage is ultimately what's driving engineers today in order to make sure that they understand what is in the actual catalyst, and then ultimately how do you optimize that based on what somebody's doing. Whether or not they're sitting there idling or they're using the piece of equipment at full load. So ultimately, as we walk forward in terms of stage 3, stage 4, and stage 5, now the challenge becomes how do we go forward with the additional PM reduction in order to meet the next level. As was mentioned before, the ultimate solution is a filter to go in the system. But how does one go forward with doing that, knowing that ultimately the SCR solution was the primary path that FPT has gone down? So this is an example of a path that we are using for implementation for stage 5, which is basically using an SCR system, which is an SCR catalyst on filter, in order to solve that issue, in order to not have a separate system or a separate can. The benefit of that is the package environment doesn't require an additional can or package space for the piece of equipment. That challenge used to be on highway products, where ultimately, where did they find the solution? That now has moved to off-highway, as many as you know, in terms of where do you put all the different catalysts? How do you package that? How do you make sure that's in an environment that's safe? How do you make sure that's in an environment that stays warm? So ultimately, this is the solution that we are using to go forward. So how do I compare that from an overall contrast perspective in terms of the benefits of the system? The three categories that the way that we look at it are the productivity, the operating costs, and overall how is it installed in the system. And ultimately, those are common trade-offs that all of us from an OEM perspective are looking at. So when we look at what stages are going on for FPT in the future for what would be a stage 5 product, all of these are being met in terms of the solution with an SCR on filter system. So whether or not it's maximizing the power, after treatment temperature, that ultimately has been a challenge for the industry in order to maintain the temperature in the system based on how the product's used. It's similar to DPF regeneration that used to be used all the time and the industry went through in terms of DPF regeneration on highway. Optimizing the after-treatment system, maintaining that temperature no matter how the product's being used, whether it's sitting there idling or not, is ultimately what is challenging the engineers today. Uptime, we talked about that before. Overall fuel consumption, and then overall life of the system. We talked a little bit about the warranty. Most of the products today, as you know, has been to optimize the after-treatment system in order to make sure that doesn't bother the customer either from downtime. And if you think about it from an off-road perspective, it's very, very different from on-road. In order to get to a dealer, you're going to have to tow that machine all the way across wherever it's going. It's not something that you can actually do that's similar to on-road. So that is a significant important item for products as we go in the market today. And then overall installation, the customer doesn't see this so much, but in off-road, as you know, there's lots of equipment that customers use. Today, the challenges that we face is that on combines and plows, they end up trying to push the limits in terms of how much equipment they can put on their product, and they continue to add it more and more. Okay, so I'm going to try to conclude here. Ultimately, in order to make and meet the stage 5 emissions, a DPF is required. We talked about that before in terms of the reduction in particulate that's required. Using the high SCR or efficiency technology is ultimately where FPT is going forward. And then ultimately having a system that doesn't bother the customer from either from a warranty perspective or a maintenance perspective. Ultimately, what's being developed today to be introduced in 2019 and 2020 is the second generation of that product with an SCR and filter. And then ultimately, without the EGR performance and the requirements and cost, that's our used for being able to optimize that system. And with that, I think that concludes my presentation.